Today we'll be going through a quick tour of pain pathways. I'll be your tour guide. I'm Dr. Kelly Jaremko. Beginning with sharks, probably not where you thought we'd start. However, swimming with them can be a daunting task, as well as getting through this lecture in a short period of time. If you were swimming with sharks and you had the unfortunate accident of being bitten, a signal would be transmitted from the site of injury up to your brain. Ow! How did that signal get there, and why do we feel pain? These are the questions we will answer during the lecture today. There are four main steps in the pain pathway, the first of which is transduction. This is the process by which tissue injury is converted into chemical signals and then electrical activity that can be passed between neurons. The passing of the signal between neurons is called transmission, and this passing of signals between neurons can be modulated by descending regulatory pathways as well as chemical modulators that we will discuss later. Ultimately, the perception of pain is twofold. First, the localization and recognition of tissue injury, as well as the experience or emotional component of pain. Transduction of pain occurs when tissue injury is caused by mechanical, thermal, or chemical sources. This causes a signal to be sent through a peripheral nociceptor up to the brain. When this peripheral nociceptor is aggravated, it releases neuropeptides, which prime the local environment to then release other modulators that upregulate activity of this neuron. That occurs by sensitizing the nociceptor so the threshold for firing action potentials is actually decreased. There are two main types of nociceptors. The first is the unmyelinated C fibers, which are the smallest and slowest that transmit dull pain. Myelinated A delta fibers also transmit pain. They are moderate speed and transmit sharp pain. Overall, nociceptors are neurons that transduce and carry the signal of pain up to the brain. This is accomplished by taking chemical signals, binding them to receptors on the cell, and then changing that into ions that come into the cell, calcium and sodium, that trigger an action potential. This action potential then can spread from the dendrites past the cell body through the axon and to the following nerve. In the case of pain, this would be the second order neuron in the spinal cord. Transmission is accomplished from the periphery by a first order nociceptor, which converts tissue damage to this electrical signal we've been talking about. The second order neurons are located in the spinal cord, and there are two main types, those that are responsive only to noxious stimuli and those that are responsive to both noxious and innocuous stimuli. They're located in different areas of the spinal cord, however, they both travel up to the brain through the lateral spinothalamic tract. Once this goes through the spinothalamic tract, the thalamus is the main relay station, which propagates the signal to the reticular system, hypothalamus, periaqueductal gray, and the cortex. Modulation of these signals occurs from descending pathways in interneurons. Inhibitory and excitatory interneurons modify the nociceptive signal along the path and can upregulate or downregulate the ultimate signal that the brain receives. Glia, or helper cells that are located throughout the central and peripheral nervous system, may increase pain signals, and further work is looking into that now. Endogenous opioids decrease perceived pain and have multiple different types, so there are many things that are modulating the signal throughout the pathway. There are also descending pathways that specifically act on those points of interest between first and second order and second and third order neurons. Those pathways include the periaqueductal gray, the midline raphe nuclei, as well as the dorsal horn. The perception of pain can be broken into the logistical component, which is localization and quality of pain. When pain occurs as a result of an injury, that can be called nociceptive pain. The type of pain under this is determined by where the injury occurs. If it occurs in the periphery, bones, joints, muscles, skin, and can easily be localized, usually you can point with one finger to where this hurts. That's called somatic pain. When pain occurs in an organ, it's transmitted in a different way, and we feel it as crampy, dull, aching, often referred pain to odd sites like your shoulder, and it's very difficult to point with one finger to where it hurts. There's also a third type of pain that occurs when we can't tell where the observable injury was, and this can be described as burning, shooting, stabbing, tingling, and can result in pain syndromes such as phantom limb pain and allodynia, where non-painful stimuli are perceived as pain. Ultimately, our subjective experience of pain is very complicated, something that we've been discussing for many, many years and centuries even, and we still don't fully understand why everyone's pain experience is different. We do know that prior experiences, expectations, mood at the time, genetics, gender, and structural changes can all impact our experience of pain. So let's recap. Transduction is the first step in pain, and this is when an injury causes chemical modulators that stimulate A delta and C fibers and create action potentials that can be transmitted between neurons. The signal travels from this peripheral nociceptor to the spinal cord as a first-order neuron to second-order neuron synapse. And then this signal is carried from the spinal cord up to the thalamus by the lateral spinal thalamic tract, and then further into the cortex. The signal can be modified at multiple different places along the path, including through interneurons, glia, endogenous opioids, and the descending inhibitory tracts like the periaqueductal gray. Perception of pain has to do with whether it is localized in the periphery of the body or in visceral organs, and our experience can be influenced by many personal factors, including our mood. Well, that about wraps it up. Thank you so much for listening today. Special thanks to the American Society of Regional Anesthesia and Pain Medicine and supporting their special interest groups to follow their mission. Our mission is to improve pain education for all medical providers, starting at medical student and training levels, to better help our patients. Please remember to fill out the post-test and compare to your pretest, as well as sending us feedback so we can make these webcasts better. Our website is through ASRA, as listed below. We have lots of resources for members, and stay tuned for future webcasts. Thank you. As one of my colleagues recommended, I figured I should end this video coming full circle back to sharks. So interestingly, there is a debate that is ongoing about whether fish, including sharks, can feel pain. They don't have the traditional nociceptors that we have described in this video, such as C fibers, and they don't have the elaborate pathways, including the neocortex and some of the perception that we assume is important to perceiving pain. This has not been extremely well studied in sharks themselves, so if any of you are budding marine biologists, this is a topic of interest. I'd love to learn more. Please send us any additional information on this in the comments, and we really appreciate you watching our video. I hope you learned something today. Thanks, and bye.